All right, I'm Patrick Moffett, Cloud Solutions Engineer for VMware, specializing in multi-cloud management. In particular, I came over with the SaltStack acquisition, and therefore that controls a vast majority of things that I work on. Ultimately, what we're looking at today is how to deal with particular cases in Windows. In specific, we're going to look at something like an application installation where we want to perform some amount of kind of high-level monitoring, ensure that a service continues working after installation, and then what things that we can do in response to that. A little bit of what this looks like in terms of implications on what we do with our systems. So in particular, at the upper right-hand side of the screen here, this is actually the event bus on the Salt Master. So we have an opportunity to see events that are coming through. We're actually going to look very specifically at events that are tagged for this particular machine. So this is it's called JPM Demo Win 2019. This is a machine that has just been newly provisioned. The only thing that's happened to it is I disabled secure browsing mode in Internet Explorer so that I could then download the Salt binary and get things installed. But otherwise, this machine is pretty much pristine. It's rebooted once as a result of handling its name change, and that's about it. So pretty much just kind of taking a quick look at what we can do from the perspective of the Salt console and how we interact with these machines. I see that I have this machine, haven't really performed anything against it. It actually still shows that its presence is set to disconnected, and that's as a result of this machine hasn't sent any returns back to its local Salt master yet. Let's take a quick look at a couple of the things that we're going to do. In this case, we're actually going to install IAS. And so the first part of this is we'll create or I have already created a salt state that allows us to handle the Windows Server Manager aspect of performing that feature or role installation. Um, I guess in this case it's a feature of IIS. Candidly, I have not been a Windows administrator for long enough to not remember specifically what all needs to be installed for IIS to work. I'm actually just going to do recurse true, and I will allow Server Manager to just install everything in the web server tree. I'm sure that includes FTP and a whole bunch of unnecessary things, but we'll just let it do its job. And then finally, at the end of this, we're going to ensure that the W3 service, the World Wide Web publishing service, is currently active, and that it's in this sense, enable true means that we're going to ensure that that service starts at the machine boot time. So that being present, I can actually go back over to my targets and I can kick that off. So I can say that we're going to run this job. I've already created a job definition for it. We won't get too deeply into exactly what that looks like, but needless to say, we're going to basically do a state.apply and we're going to tell it to run that specific IIS job that we already kicked off. So while that's running, it'll take a second to kind of figure out what's going on. While that's going, we'll monitor that to kind of see what's going on. But ultimately, this gives us a couple of minutes to kind of review the things that are going to happen next. Once that service is in place, and in the normal context where we look at doing something like provisioning a machine, my next step is I now have this essential service. I want to ensure that it's up all the time or most of the time, or at least that it's available to the extent possible. And so one of those concerns from a monitoring and operational standpoint is how do I now take care of, without having to necessarily reach into other monitoring suites and go through, webhooks on top of webhooks and go through a whole bunch of things. If I'm looking at using Salt as a change management tool, essentially, it already is talking to that individual minion on a regular basis. Can I do something like inject, in this case, a beacon to compel that machine to essentially self-monitor the status of that specific system service. And that's fairly straightforward from Salt's perspective. There is a function within the Salt engine called beacons, and it basically allows individual minions to inspect some measurable on its local system. And when it sees either a change or even just because we want to look at these things on a specific period of time or something like that, or we see file system utilization creep over a certain amount, we can actually compel that minion to send an event to the master's event bus, which again is up here at the top right. So right now, what you'll see in here, looking just in this area, we did kick off that job, and because that job is destined for this 2019 machine, we see that job data there. Um, so we know at least that that machine is in the process of kind of being compelled to handle that. If you're looking at that, I'm honestly not keeping a super close eye on that part of it. The screen looks different for you than it does for me. But when that job starts returning, we should see some things in there. We'll also see when we implement this beacon after the service itself is already installed, we should be able to see events. In this case, we have this set to on change only true, which means that the beacon should only trigger if we see the actual state of that service change while these things are going on. So if it sees that the service has flipped from being running to being stopped or error or um, any other condition that is not running, then we will we'll take care of. In this case, we'll get into the reactor discussion a little after this, but that's where we get to the point where we have identified that there's an operational issue that we need to do something about, and we have some ways to kind of formalize, what we do with those types of situations as well. Ultimately, there's a little helper script that I've kind of installed here. We can actually we can represent beacons as a flat file in the minions file system, and that will actually be loaded. So if we're doing something like drop shipping or something else, we have some other way to either templatize or manipulate the file system of a specific minion before that provisioning process or during that provisioning process. We actually can substitute some of this. We can kind of pre-pack beacons that we know that we're going to want for particular systems. In a lot of cases, it's going to be something along these lines where we're looking at specifically monitoring something like a specific service, or maybe we want to do something like monitor C drive utilization on all of the Windows machines in the environment. It would be fairly trivial for us to do something like insert a disk usage beacon across all of those machines that we deploy. Um, on the other side of that kind of chain of events, the idea that a minion can compel the publication of an event to the master's event bus, we also deal with what are we going to do about it after that happens. And so that occurs in what we call a reactor. The reactor is a separate engine that's available to Salt Masters, and this really gives us the ability um, to essentially inspect what we call tags. I don't know if it's clear here, but in the case of, sorry, let me make this bigger so that I can see it. Um, where we're looking at, in this case, we see that there was a minion refresh. So it was, so the master was compelling this individual minion to perform a data cache refresh. So this right here is called a tag. When we're looking at the way that we deal with reactors, where we want to take actions in response to some event that comes across the event bus, these are the types of things that we're going to inspect. There's a tag here for this new job coming back from or being at least distributed to that machine. Actually, it looks like we just had that job complete. It's done handling that IIS installation, so we can actually see all of the job output from that. So let's jump over to the activity console. We can see that completed job, and we can see what the result of that was. We'll get into the reactor discussion in just a second. So um, we see that it splits the state run into a couple of different parts. I happen to name the running state something that takes order precedence over the actual installation, but that ultimately occurred right here. So that's some really horrible formatting, but ultimately these are all of when I told it to recurse through everything in the web service tree, these are all of the things that it decided to grab. So client authentication, CGI, ASP, ASP.NET, all of those things does explain why this specific job took a little while, but not a huge deal. So we can see in the typical context of when we do something like package installations, or in this case where we're looking at feature or role changes, we're going to make that observation, and this is true of pretty much any other time that we do something like we made a change. Salt jobs, the returns come back with a changes dictionary, and that ultimately is there to outline all of the things that happened as a result of carrying out a specific task. So in this case, the new value of this specific feature is what's represented. When we see that the old dictionary is blank, it means that it wasn't there before. So pretty much everything that we're seeing here, where we might see the old dictionary populated, might be we do something like carry out an upgrade or a patch process or something like this. So we see that there's an application, whatever, 7-zip or something like that. We had version 1.19 or something like that, and we installed 1.21. We'll see the older version and the old part of the dictionary, and we'll see the new version in there. So from a change management perspective, we're capturing all of that information about what was there before and what's there now. So ultimately, in terms of if we need to do something along the lines of carry out rollbacks or even just be informed about what the prior state was before we decided to make changes. That's ultimately how Salt tends to note these things. And it's worth, kind of noting that this installation took 6 minutes. It went through 57 changes as a result of this activity. And at the end of this, it did actually, handle the installation. I didn't have to reboot. I have the ability to do things like inspect for pending reboots. That's ultimately a system metric that we can inspect. If we wanted to do something like do a report across all of our Windows minions after doing something like carrying out patching. If we're doing that through Salt, fine. If we're doing it through SCCM or something else, then that's fine also. At the end of that process, we actually can do things like inspect for, is reboot pending on this specific device, and then make decisions based on that information. If there is a pending reboot, then carry that out. Wait X amount of time, or actually wait for that specific start event tag, so we know when that distinct machine has restarted, and then we know that we can either continue the patch set or at least inspect if there are other patches waiting, and then carry those things out. So ultimately, something like that might become a longer term orchestration, but those ultimately are things that we can do. So now we know that IIS itself is installed and running. We can go through again looking at this specific beacon. We have this kind of helper state here that we can introduce to handle the installation of the beacon itself. So I'm going to jump over back to targets. I'm going to look at my Windows servers. We see that this guy's presence indicator has gone to present because we have a return now, and we'll handle the installation of the IIS beacon now. So here's the state that it's going to run, IIS.beacon, and I can actually handle that state run right now. Over on this side, we should see the new job when it's issued to that specific minion, and then we should also see when it comes back. So that's in progress right now, but it's running, and probably just a second over on this side. Actually, I see the success already came back. Um, so I can see that that occurred, and I can see that I can look at that individual state. It says that it successfully installed this beacon. And then it did actually save that. So there is actually a beacon file on that individual machine. So when that machine reboots, that beacon will still be instantiated when the salt minion starts on that machine. So I guess the first thing that would be worth noting is if I jump over to this guy, we can do, let's go to our services here. And we can actually jump all the way down here and we can look at the World Wide Web Publishing Service. It's the oldest sounding service name I've heard in a long time, but ultimately there it is. We can inspect for, again, the running status of this specific service. So candidly, I already handled the reactor installation. We'll take that apart in just a second. But if I were to turn this off, we would see an event trigger as a result of that beacon. There are a couple of settings that it's worth taking a quick look at, just in terms of when we want beacons to trigger and when we don't. And so from that perspective, a couple of just kind of housekeeping issues here. We can load beacons into memory, and if we don't indicate that we want to save, then we can temporarily instantiate that beacon, and then whenever the salt minion on that machine is restarted, that beacon will be absent. There's also the concept of enabling and disabling beacons. So, if we have longer term maintenance activities or for whatever reason, if we have failover behaviors or something like that, so we don't want beacons to always be enabled, we have the ability to interactively enable and disable beacons as well. And then finally, a couple things here. The on change only attribute allows us to determine that we only want this to fire when we see that the status of the service itself change. We're also setting the interval to 5. The default interval for beacons is literally once a second. In this case, we'll slow it down to once every 5 seconds. Um, if we didn't select on change only and we didn't specify an interval, it would literally send an event to the salt master to indicate the status of this service once a second. Ultimately, in terms of, we're sending a very small amount of Unicode text, probably not too big a deal. But if we do that times, thousands of servers, then it starts to kind of add up. The last attribute here that we're going to look at is disable during state run, and this isn't really going to be particularly important right now, but it is important to note that if we're doing something like carrying out a maintenance activity, which if you're looking at my file system over here, you see that's going to be part of what comes up here, but we can actually programmatically enforce the disabling of individual beacons while we are carrying something else out. So if I've decided to carry out a change action against a specific machine, we've scheduled maintenance window and all of those things, in terms of do I need to now remember to manually or automatically disable the beacon before carrying out that maintenance activity? The short answer is no. So if I do set this specific argument when I create that beacon, I can be at least fairly well assured that that beacon won't fire right when that maintenance, while that's still going on. We won't try to, in this case, restart something like IIS while we're going through either updating web application content or something else like that, or patching or something like that, where it would be problematic to try to restart the service while that activity is happening. The caveat there is that ultimately that beacon will fire as soon as that state is over. So if it sees a change from the, if the state run has completed, and now the beacon identifies a change in that service status, it will kick that off pretty much as soon as that activity is complete. So um, on the one hand, that's helpful because you don't have to necessarily remember to restart that service. It will do its job after that activity is completed, after that state run is over. But if you're not expecting it to start up right away, then that's something to take note. We do have a couple of other things. We have delays, and we have other ways to kind of manage whether or not events fire, or even in the actual job itself, where we're doing something like remediating the status of the service itself. We can kind of manipulate the way that we take care of certain conditions at that point as well. So, as far as the reactor system is concerned, the salt master has to know a couple of things. This actually right here is just a helper state to insert the reactor configuration. Ultimately, I wanted to make sure this wasn't a smoke and mirrors experience. I am in this case specifically seeding a reactor configuration into the salt master's configuration that has to be present in its ops or in pillar. One way or another, the master has to know specifically which events it's watching and when. And then finally, we are restarting the master service if we hadn't already handled the installation of this reactor configuration. So just looking really quickly at the reactor configuration itself, I'm identifying specifically that I want the reactor engine to be present so that it is actually able to load this reactor configuration. And then I'm giving it specifically this tag. So we'll actually see here the beacon actually did fire, that our running state has changed from false to true at the tail end of that. Um, or actually, I guess it previously didn't have a state. So when I instantiated the beacon, we finished handling the beacon installation. It actually did fire the beacon because it has to record the very first time that its status has changed to true. So this ultimately is the tag that I'm inspecting for. We'll see here that I've wildcarded the minion ID here, JPM demo win 2019. In this case, we just want to inspect for literally any time the W3 service has changed status one way or another. And as a result of any time that we see that tag come up, we're going to assume that there's been a change and we want to kick off this specific reactor. We've located that right here. And so this is a little bit of its reactor syntax is very similar to orchestrations, and I have wrapped a little bit of Jinja around this just to handle some of those extra cases. So in this case, you'll see that when this actually swapped the service status to true, nothing happened, even though it had already instantiated the reactors. That's because as a result of what's going on here, I've actually specified that if the status of the service is already running by the time this reactor kicks off. There's nothing in between that bracket and this bracket, so we're actually going to template out any actions at all. So if the service is already running, then we won't do anything. So if that beacon were to do something like trigger erroneously, we're not committing massive numbers of state runs or something like that ought not to happen. Um, if the service status is in literally any other state, other than, in this case, true means that the service itself is running, uh, then we will kick off a state.apply, and we're actually looking at literally just that same IIS state. Actually, I should modify this. It would just in this case now be the IIS state. I modified this from when I wrote it. So that would actually just kick off that original state file where we're handling the role installation and then ensuring that the service itself is started. It's worth noting that typically in Salt context, in addition to kind of doing these things from the perspective of a desired state or a policy enforcement engine, Salt often stresses the concept of idempotence. If I run this state, I should expect that the individual states within this specific module should behave the same way, or the end result should be the same regardless of how many times I've run it or if I've run it before. So having handled all of those role installations, it's ultimately Salt's job to, if I were to run this state again, to determine that these things are already installed and not do that again. And then finally to ensure that the service itself is running and that it's set to auto start when the machine boots. So at this point now, we've kind of established that we can make that determination of identifying those status changes when something happens on this machine, and then we can see ultimately that reactor is in place. So if I do something like in this case, again, we're kind of watching the event bus over here. If I were to turn off the service one way or another. If it turns off, if it goes into an error state, if something else happens, wayward WMI calls or something like that. If I were to stop that service anywhere other than via Salt, then we'll actually see that we do trigger that specific beacon for the state of this machine, and it occurs to me that I didn't change my reactor configuration because I did make some changes. So let me fix that guy really quick. And so let's see, where did I hide that? Let's see, salt mess. Sorry, I'm typing in a window that you can't see. Um, reactor.conf. I changed the name of the beacon when I moved things around. And it's not very fair to everybody else. System control restart. And you'll see the Salt Master bounce in the event bus in just a second. I'm going to secretly restart the service in the back. Huh? There it goes. Oh, actually, you won't notice the master restart because I am tag matching to specifically look at this machine. So the master actually correctly restarted at that time. Now, if I do what I was supposed to do, if I stop the service, we should see that tag match come up, that the state of the IAS service has gone to false, and geez, come on, man. Oh, there it goes. That's just me being finicky about it. Okay, so the reactor state did actually kick off. I apologize. I'm missing some things because of my tag matches filtering out stuff that I'd normally see on the event bus. But ultimately, we can see that I should have noticed when this minion refresh tag came in, that was because the minion was carrying out a job. So it did actually end up reinstantiating. It kicked off that windows.ias task, and so it ran through those same service enablement steps. We'll actually see this in the console. So the last thing that I did before that was handle the beacon installation, and then after that we turned off the service and it kicked off that exact same task. First, to make sure that the web server role itself was already present. In this case, it says it installed the following web server, so it installed it, but basically there was nothing. As it goes through to recurse, there are no contents, so the web server role and everything underneath it is now present. Um, there were ultimately no changes. So you see a case where the changes dictionary is empty again because it didn't actually change anything. And ultimately, we were then also able to handle the restart of that service itself. So if I were to refresh here in my services console, I'll see that the W3 service is now running again. So that's all well and good, but what if I take care of a maintenance activity now? So I will kick off a quick state here. Let's take a look at it really quick before we run it. And we'll kick off uh, a simulation maintenance activity. It will start by issuing service.dead, ensure that the service itself is not running or disabled for the W3 service. And then in the pretend maintenance activity, we'll just sleep for 20 seconds to give a little bit of a delay. I want it to be long enough that we see that the beacon doesn't fire once the service itself deactivates. And then when this is done, we'll fire off another. This is just a state so that we know when it ends. And then we should see that everything returns to its normal state when we're done with that. So let's kick off this job. This should kind of take care of the last portion of this. And I'll kick off IIS maintenance. And we'll see over in the event bus, we'll see a couple of things happen here. So we can see that the minion refresh occurred. We don't see the tag. On the master side, there is an event for the publication of the job. We would have seen that when the reactor fired, but again, I'm tag matching to specifically inspect things that pertain only to this Windows 2019 machine itself. So I unhelpfully put blinders on myself for a little bit of this, but ultimately we'll see, what things go on. So we can actually see in the console itself that the job itself, that task is still running. We can see that there's one minion that hasn't returned yet. I can kind of glance over in my event bus and I can see that we're getting returns back from this minion. Um, and then ultimately, as soon as that return came back and the job was finished running, we see that there's a tag match in here for that beacon. So I just see that that it reinstantiated its installation. So I'll just kind of pretend that didn't happen yet. It was too fast for me. But we can see that as a result of that maintenance activity, we handled disabling the IIS service. It is now false, which means that it's not running. Um, we then did the sleeping for 20 seconds, and the duration was 20 seconds, which is fantastic. And then we had a succeed with changes. We see that the maintenance activity is done. The total time to do all of those things was 32 seconds. So there was a 20-second sleep, and it took about 12 seconds to shut IIS all the way down. Um, if we're looking at this, we can also see that once that activity completed, once that job was done, that beacon fired immediately on the conclusion of that job. And so we can validate that both the disable during state run flag works as expected, and also that once that's done, the beacon returns to its normal status. So we can see that it did the same thing that we would normally expect. It ensures the presence of the web server role, and then takes care of the reinstantiation of the W3 service, so we can ensure that it's running. And that took about 12 seconds also, so it seems to be pretty consistent across all of our state runs. So pretty much start to finish, that gives us, comprehensive control over what goes on in our Windows environments, installing applications, inspecting for changing conditions on the machines, and then optionally responding to them. Reactors don't have to be uh, limited to actually a number of things. They don't have to be limited to doing things like restarting services. They also don't have to be restricted to the individual machines that called out an event in the first place. So if we want to do something like raise events to a chat ops channel, Microsoft Teams or Slack or whatever else, we want to let people know that a certain condition has occurred, then that's totally fine. If we wanted to do something else, maybe from a security standpoint or something like that, if we see some specific event, whatever, unexpected login activity or something like that, we actually can carry out events against entirely different machines. So if we want to do something like instantiate a firewall rule as a result of activity that we see on specific machines, then ultimately we can do that. We have a lot of flexibility in terms of what we do and when. Ultimately, it really just comes down to that ability to codify, these are the types of conditions that compel some event in my infrastructure. And then typically, if we've been going through these things already, then there's already a salt state that I know that I want to commit as a response to those changing uh, um, conditions in the environment itself. I hope this gives a little bit of insight into how we can kind of control and manage, not just on a configuration deployment day one type perspective, but also handle the ongoing management of machines in our Windows environments. Again, Salt gives us a lot of power to be able to kind of handle these things from that declarative perspective. You saw that with multiple state runs where we're handling that IIS installation, we're literally just running that exact same state again during any of these reactors where we want to handle restoring service to this specific system service, but we're still inspecting for that correct installation. So where we have other steps where we want to do things like ensure that the configuration is looking the exact way that we expect it to, where we're trying to address things like configuration drift, we have the ability to do those things as well. I hope this is helpful to you. If that's something that can assist the operational teams, happy that this can be of use to someone. Thanks so much. Bye bye.